Thanks for coming out to build today. My name is Edward Thompson. I'm a program manager for Visual Studio Team Services, and I work primarily on Git and version control. I've actually been working in the version control space for an embarrassingly long time. So one of the things that I'd like to do today is to talk about some best practices when it comes to using Git as far as your branching strategies and how that can affect your deployments into production. And like I said, I've been doing this for a long time, and our thinking on this has changed a lot over the last, say, 10 years. So when I started working at Microsoft about 10 years ago, I was a developer on the Visual Studio Team Services team, and we did our branching very differently. At the time, we were using Team Foundation version control, and the Visual Studio Team Services team was sort of part of the Visual Studio team. We shipped at the same time and at the same release cadence. So it made a lot of sense for us to be in the same repository with them. So we used, and we actually recommended, a very branch-heavy branching model. We had a main branch, which is what we shipped, both the Visual Studio IDE and Visual Studio Team Services. Since they were at the same release cadence, we were, again, all in one repository. And to separate our actual code bases, because we didn't actually share any code, we made a branch. So we had a group branch for the IDE team and a group branch for VSTS. And to get code flowing back and forth, we did integrations, we did merges. And so we would take all the code that we'd been developing on VSTS and merge it down into main. That would give our friends on the Visual Studio IDE team the ability to see it and use it. And they'd do the same thing at the same time. Once that all got done, we then merged the other direction. We brought all that merged code back up to us. This was complicated, to put it politely. We actually called it merge hell, because we would have these big bang merges and it would be nothing but conflicts, and it was miserable. But we did it. We did it a lot throughout the course of a product release. And we were so enamored with this branching strategy that within the VSTS team, we would create another set of branches. So my team, maybe the version control team, would create a branch off of our TFS and VSTS branch. And we would do the same sort of integration schedule. And even beyond that, we might spin up feature branches to do some work in isolation from other teams. And then, of course, we had release management branches. This was terrible. Do not do this. You know, if you're looking at this like, oh, hey, that's a good idea, please do not. Right? This is really, truly merge hell. And there's a thinking in organizational patterns. It's called Conway's Law. I won't read this for you. But the idea is that you tend to build and ship the org chart. The way you manage your teams and the way you split up your teams and then split up the software development projects reflects your org chart. There's kind of a corollary to that. You tend to branch the org chart. And that is really regrettable, because branches really stop the flow of code between people. What we now recommend on the VSTS team is a trunk-based development strategy. The idea is that you code in master or close to master, and you make small, simple changes and get them integrated into the master branch as quickly as possible. The goal here is to have fewer merge conflicts. It enables code review because you're looking at smaller chunks, right? It's really hard to code review thousands and thousands of lines of changes. It's much easier to code review a small chunk. This will let you ship faster and get your code to your users faster. Now, a lot of people wonder, well, what if I'm not done with a feature? That's okay. That's where we would recommend that you use feature flags. Right? It used to be that we would recommend branching to do feature work so that you kept that away from consumers. But My buddy Ben Day, he says that branching is an integration credit card, and you've got to pay that debt off sometime. So what we would encourage you to do, instead of keeping your code isolated from the other developers that you work with, keep your features isolated from your end users until you're ready to release them using feature flags. So a trunk-based development strategy is quite a bit simpler. We have a master branch. And if I want to, say, fix a bug, I spin up a new branch, fix the bug, get that merged into master quickly, and then I forget about that branch. It's gone, no more. Very ethereal. I don't have to worry about debt accumulating that I have to deal with in the form of merge conflicts. As I do feature work, I get that integrated as quickly as possible too. So everybody on the team is making a branch, making changes in that branch, and getting it merged very quickly. Let's take a look at what that looks like. So here I have Visual Studio Team Services. And obviously, I forgot to quit Outlook. So Visual Studio Team Services, when I tend to start working on a new feature or on a bug, I tend to do it by creating a branch. And we actually guide you through that workflow in Visual Studio Team Services. Right over here in this work item form on the far right, I've got a link to create a new branch. So this will create a new branch off of my master branch. I'll give it a descriptive name, click create, and that creates a new branch on the server from master. If I want to start working, I can just git fetch that branch down to my local repository, check it out, write some code, make my change, save it, check it in, again, just to my local repository, and then push that change up to the server. Okay? So now I've made a change in my branch in isolation. I want to get that change integrated into the branch, and I want to use a pull request to do that. When I come back to Visual Studio and hit reload, it will see that I have actually pushed a change in my branch up to the server and walk me through the pull request pipeline. So it's guiding me down this trunk-based development workflow. At this point, I can get code review, I can collaborate with my coworkers on the best way to make this change. If they have some input, I can do a continuous integration build and a test pass to make sure that my code is up to quality standards. And when I'm happy with it, create that pull request and then complete the pull request, which actually does the merge into master. Okay? So very simple, very straightforward to get code into my master branch and ultimately deployed to my customers. Okay. So a lot of people look at these trunk-based branching strategies and conflate them with something called GitHub Flow that you might have heard of. GitHub Flow is a trunk-based branching strategy, but it adds another layer of complexity onto that that often goes unnoticed. And it talks about how you actually do your deployments. And this is actually really a cool way to do it. It's continuous deployment, and this is the way GitHub works to build GitHub.com. So this is what I used when I worked at GitHub, and I liked it. So the idea is very trunk-based, right? You create a new branch, you make some changes in that branch, you open a pull request, collaborate with your peers, right? So far, very standard. And then there's something that often goes unnoticed, that little squirrel right before the pull request gets merged. At GitHub, the way they work is they actually ship their pull requests to production before they merge them. It's total, it's a subtle thing that goes unnoticed. I didn't even realize it until I started working at GitHub and working in this manner. But it's really cool. So GitHub uses chat ops to manage this. So they hang out in a chat channel and ask their friendly robot, Qbot, it's a chat bot, to do the deployments for them. So the way this works is, if I have a pull request that I've opened, I go into the chat and I say, hey, can you deploy that pull request to production, right? I've opened the PR, I've gotten code reviews, everybody's happy with me. I ask Qbot to deploy it to production, and Qbot does. So the first thing that he does is make sure that everything's building, that tests are passing. Once that's done, he actually does the deployment. So he packages up those build artifacts and deploys them to the server. At that point, I'm supposed to make sure everything's good. And when it is, then I actually close my pull request. I complete my pull request and merge it into master. So continuous delivery at GitHub, every pull request gets deployed to production. So the master branch is always what's in production, or there's something being tested in deployment. It's very cool. It's very effective. And I like this strategy a lot. So fundamentally, the way GitHub Flow works is that the master branch gets locked. This is very important, so that only one person is testing a deployment in production at one time. Then you merge master into the branch to deploy so that you never overwrite anybody else's changes. You want to make sure that you have all the changes in master as you're about to deploy to production. You do a build. You might deploy to a canary set of servers. So you can do some staged deployments to make sure that everything's working OK, right? If you wanted to introduce some change that broke everything, it's better to do this at a limited set of servers, so you're not taking everybody down at once, right? So if you're nervous about your changes, you might deploy to canary first and then do your monitoring. Finally, you deploy to production, and again, make sure everything's working OK. Once you're confident that your change went well, then you merge the pull request. And what that does is it unlocks master, so the next person can do their test deployment. This is really cool, and I like it a lot. If you want to do continuous deployment, I really recommend this strategy. The problem is it stops scaling at some point. Because if it takes 5 minutes to do your build and tests, it takes 5 minutes to deploy and do some monitoring in a test set of servers, and 5 more minutes to deploy to production, that doesn't sound like a lot, but that adds up really quickly. Because, so again, when I was at GitHub, when I started in 2015, we were doing about 150 deploys a week of GitHub.com. So we were merging 150 pull requests. When I left a year later, it was closer to 450. This stops scaling when you're doing that many deployments. So that's not actually what we do on the Visual Studio Team Services team. Because what happened even at GitHub scale, is that sometimes you would come in, maybe on a Friday. Fridays were a busy time. And you would say, hey, I want to get in the deployment queue. Because again, we had to lock production so that only one deployment was going on at once. You don't want to conflate which deployment is causing problems if there are problems. So I would get in the deployment queue with my changes. There are 14 people ahead of you in the queue. And come, I don't know, 6:30, whenever I was ready to go home, I would unqueue myself from deployment. So I never got my changes actually deployed. So if you want to do continuous delivery, it's great. But unfortunately, you hit scaling issues at some point. And when you do, you can do what we use in Visual Studio Team Services. So Visual Studio Team Services, like GitHub, will host your Git repositories and allow you to collaborate on them with your coworkers. But we're more than just that. We offer agile planning tools. We offer, once your code gets checked in, we can build it in the cloud and we can deploy it. So we're a much bigger footprint than GitHub is. So it takes us longer to build, it takes us longer to deploy, and we deploy more places than GitHub does. We're very geographically distributed. VSTS deploys to multiple scale units across various Azure data centers across the globe. So instead of doing continuous deployment, we do something that we call release flow. Now, release flow takes our trunk-based branching strategy and adds an idea of how we want to deploy it to our servers on top of that. So instead of deploying every single change that a developer makes, right? We got 300 people working. We just could not ever do that. We deploy at the end of every sprint. So for 3 weeks, we work on a sprint, we build features, and at the end of the sprint, we're ready to deploy that. When we do that, we create a new branch off of the master branch. So for sprint 120, we call it M120. And we deploy that to production. After those 3 weeks are up, when we're ready to deploy a new set of features, we throw that branch away. It's done. Have no use for it anymore. We create a new branch, M121, and deploy that to production. Now, you might be wondering why we don't just deploy master if the point of this branch is to throw it away. Well, regrettably, we're not perfect. We do actually have bugs that we deploy to production, and we need to fix them. And so when that happens, what we do is we create a new branch off of master, and we fix the bug in master first. Once we've got the bug fixed in master, we cherry pick those changes. So we bring that pull request, a new copy of that pull request, into the release branch. Now, the reason we do it that way, because it takes a little bit longer. Like, if we have an availability issue, we want to get it fixed as quickly as possible. It doesn't make a lot of sense to make a change, get it merged into master, which isn't in production, and then cherry pick the change into production. But what it does is it ensures that we always have that change in master. Because again, we blow these branches away at the end of a sprint. There's a risk if we made the change directly in the production branch that we would forget to bring that change back to master. And then the next time we did a deployment, it wouldn't have that bug fix, and we would have the same availability issue. And that is absolutely unacceptable to us. So it's worth taking that extra minute or two to get it into master first, to get it code reviewed there, to test it there before we actually bring the change into production. So we actually have some really nice features built into Visual Studio Team Services to support this sort of a workflow. So this is actually the VSTS repository. This is where we actually work. And this was an issue that we had in production. I mean, it's not a serious issue. It's a typo. We said that something, it lightens, and we wanted to fix it to lights. But the way we do this is we make the change in master, and then there's actually this button right here. Once the pull request gets merged, the cherry pick button. What this does is it will take the entire pull request and retarget it on another branch. So once this lands in master, we click cherry pick and create a whole new pull request against our production branch. And that shows up right here. So this one is now targeting releases M134. So that's the way we actually bring changes into production. And in fact, if you want to go outside of this, if you want to make a bug fix for a production branch and not go through master first, you actually have to fill out a little form. Is this fix already in master? No. And explain why not. The risk of regressing bugs is so high that you actually have to sign off and explain why you're doing it this way. Okay? So this is the branching strategy and the release management strategy that we've come up with while we've been building Visual Studio Team Services at a scale that can support the development of all of Microsoft and hopefully your development as well. If you are building software and deploying it to production, I really recommend you take a look and think about this branching strategy. You can read more about it. You know, this was a super quick introduction. You can read more about it, dig into the details at aka.ms. release flow. If you have any questions, I'll be sticking around here for just a minute. I'll be over here. I've got to get to my next session. If you want to learn how Windows uses Visual Studio Team Services to do their deployments, come find me at 1:15. But otherwise, you can hit me up on Twitter. I'm E. Thompson if you have questions. Thanks so much, everybody. I really appreciate it.